JWST reveals 2,500 hidden galaxies in Hubble Ultra Deep Field. Redshift Cosmic History Explained. Prepare to have your mind blown. Astronomers have just peeled back another layer of the universe's ancient past, turning one of astronomy's most celebrated images into something even more astounding. Ready for a cosmic tour that could challenge everything you thought you knew? Here's the story most people don't hear. More than 2 decades ago, the Hubble Space Telescope gazed intently at a seemingly empty speck of sky for several days. This ambitious project led to the creation of the Hubble Ultra Deep Field, a breathtaking vista capturing light from about 10,000 galaxies, some so distant that their light began its journey when our universe was less than 1 billion years old. Just to put it into perspective, Hubble required 400 orbits and more than 270 hours of exposure to give humanity this extraordinary peek into our cosmic origins. But here's where things get controversial. Could we go even deeper? Enter the James Webb Space Telescope, JWST, designed to exceed even Hubble's immense capabilities. Recently, JWST spent nearly 100 hours, its longest extragalactic gaze so far, studying a section of the Hubble Ultra Deep Field that contains roughly 2,500 galactic sources. By utilizing its impressive arsenal of near and mid-infrared instruments, Webb has managed to capture the universe's faintest and furthest galaxies in ways that were previously impossible. Now, if you've seen the new JWST images, you might notice a rainbow of false colors. Why? Unlike Hubble, which observed mostly visible light, JWST specializes in infrared. When translated into colors we can see, longer wavelengths detected in the mid-infrared show up as reds and oranges, revealing secrets about interstellar dust, active star formation, and even the supermassive black holes that often lurk at galactic centers. In contrast, blues and cyans represent galaxies emitting nearer infrared light, often missing large amounts of dust or furious black hole activity. But wait, there's more. The image also features galaxies shining in greens and whites, representing the middle range of JWST's capabilities. These galaxies are the most distant, their light stretched by the accelerating expansion of the universe, a phenomenon known as redshift. And this is the part most people miss. By separating galaxies by color in a single image, astrophysicists can better untangle the timeline of galaxy evolution, pinpointing which cosmic epochs they belong to. Let's not forget how groundbreaking Hubble's original deep field was. It gave scientists their first real handle on what galaxies were doing in the universe's earliest days. But now, JWST is poised to deepen our understanding even further, revealing details Hubble could only hint at. Here's a perspective to blow your mind. The patch of sky photographed in the ultra-deep field is astonishingly small. If you hold out a ballpoint pen at arm's length, the tip covers about as much of the sky as this entire survey. Yet, inside that tiny area, astronomers have found hundreds, now being scrutinized at unprecedented detail, of the farthest and oldest galaxies ever discovered. But here's a point for debate. Can these telescopes ever show us the true beginning? Or are we always limited by the boundaries of our technology? What do you think? Is JWST's achievement proof we're closer than ever, or is it just a reminder of how much is left to discover? Drop your thoughts below. Do you agree JWST is revolutionizing our cosmic perspective, or do you think we're still peering through a keyhole at the universe's deepest mysteries? Webb revisits Hubble's classic ultra-deep field, unveiling the secrets of the universe. Imagine gazing into the deepest corners of the universe, where time itself seems to stretch and bend. The Hubble Ultra Deep Field, captured between September 2003 and January 2004, was a monumental achievement, revealing nearly 10,000 galaxies, some of which were born when the universe was just 800 million years old. But here's where it gets exciting. Astronomers have now revisited this cosmic treasure trove using the James Webb Space Telescope, JWST, setting a new record for the longest and deepest observations of an extragalactic field ever conducted. This isn't the first time the JWST has delved into Hubble's territory. As part of its Cycle 1 General Observer (GO) programs, the telescope captured high-resolution infrared images of the galaxy cluster SMACS 0723, which Hubble had previously studied as part of the Southern Massive Cluster Survey, SMACS. The image at the top is the result of nearly 100 hours of observation using the shortest wavelength filter on the JWST's mid-infrared instrument, MIRI, combined with data from its near-infrared camera, NIRCam. This observation was part of the MIRI Deep Imaging Survey, MIDIS, a project that aims to uncover the secrets of the universe's most distant galaxies. These deep observations revealed over 2,500 sources, including hundreds of extremely red galaxies. Some of these galaxies are likely shrouded in dust, where high concentrations of interstellar dust block or absorb much of their starlight. Others are probably highly evolved galaxies with many older stars, such as red dwarfs, which can remain in their main sequence phase for trillions of years. The different colors in the image represent various kinds of infrared light, showcasing the fine distinctions astronomers can make with this deep data. Galaxies that appear orange and red, corresponding to the longest mid-infrared wavelengths, often have features that emit more light, such as high concentrations of dust, high levels of star formation, or an active galactic nucleus AGN at their center. Small, greenish-white objects peak in the mid-infrared wavelength, indicating particularly distant galaxies that have experienced significant redshift. The remaining blue and cyan galaxies, which make up the largest share in the image, lack mid-infrared boosting features and are brightest at shorter near-infrared wavelengths. The JWST's sharp resolution and sensitivity are allowing astronomers to resolve features in many of these galaxies, helping them understand the structure and light distribution. This will provide valuable insights into the growth and evolution of galaxies since the earliest cosmological eras, aiding scientists in measuring the influence of enigmatic phenomena like dark matter and dark energy. By revisiting Hubble's legacy fields, the JWST is continuing the proud tradition as deep field imaging, uncovering previously hidden aspects of the universe and its evolution over billions of years. And this is the part most people miss. The JWST's ability to capture infrared light allows it to see through the dust that obscures many galaxies from Hubble's visible light observations. This opens up a whole new world of discovery, revealing galaxies that were previously invisible to us. But here's where it gets controversial. Some astronomers argue that the JWST's deep field images might challenge our current understanding of galaxy formation and evolution. Could there be new physics at play that we haven't yet discovered? What does this mean for our theories about dark matter and dark energy? These questions are at the forefront of current astronomical research, and the JWST is providing the data we need to answer them. What do you think? Do you believe the JWST's deep field images will lead to groundbreaking discoveries? Or do you think they will confirm our existing theories? Share your thoughts in the comments below. James Webb Space Telescope reveals 2,500 galaxies in stunning new image. The James Webb Space Telescope, JWST, has captured a stunning new image of over 2,500 galaxies, providing an unprecedented view of the universe's history. This latest image was taken as part of the JWST Advanced Deep Extragalactic Survey, JADES, which aims to further probe in infrared light two patches of sky originally imaged by Hubble, the Hubble Deep Field, 1995, and the Hubble Ultra Deep Field, 2004. The Hubble Ultra Deep Field, in particular, was revisited several times by Hubble, revealing some 10,000 galaxies detectable in an area of sky just 2.4 arcminutes square, less than a tenth of the diameter of the full moon in the night sky. However, Hubble's vision is limited, and at the greatest redshifts, corresponding to galaxies that existed within a few 100 million years of the Big Bang, visible light is stretched into infrared wavelengths, beyond Hubble's capacity to see. To overcome this limitation, the JWST has stepped up, capturing its first good look at the Hubble Ultra Deep Field in October 2022 with its near-infrared camera. This latest image was captured by the JWST's mid-infrared instrument, NIRI Deep Imaging Survey, MIDIS for short, with the instrument's shortest wavelength filter taking the longest exposure of any single filter as part of this image, totaling 41 hours. The image doesn't show the entirety of the ultra-deep field, only a section of it, containing about 2,500 visible galaxies, 4/5 of them being truly distant, high-redshift galaxies. None are record breakers, with the maximum redshifts visible being about 12, equating to 380 million years after the Big Bang, or 13.4 billion years ago. When coupled with data from JWST's near-infrared camera, NIRCam, that operates at shorter wavelengths, the observations reveal a great deal about the many galaxies in the image, most of which are visible as small dots of light. The image is presented in false color, as infrared light has no visible colors, since it is beyond what the human eye can see. Hundreds of red galaxies in the image are either star-forming galaxies shrouded by interstellar dust that absorbs the starlight and re-radiates it in infrared, or are highly evolved galaxies with lots of older, redder stars that formed near the beginning of the universe. Meanwhile, the small greenish-white galaxies are those that are at very high redshift, meaning we see them as they exist mostly during the first billion years of cosmic history. On the other hand, the larger blue and cyan galaxies are closer with low redshifts and so appear brighter to NIRCam than to MIRI. Astronomers work to push ever deeper with the JWST, adding observation on top of observations to chart the development of galaxies from close to the dawn of the universe to the present day. Among the data could be answers to many of cosmology's greatest secrets, such as how supermassive black holes formed, how galaxies formed, and when the majority of stars in the universe came into being. This is all still a work in progress, so stay tuned.